Hi, good morning all. Let us try to solve this problem. 44 is using Milliman's theorem is asking us find the current through IL of 10 ohm in the network. Okay, so already I told in the previous lecture 43 I have been explained you about how to perform this reduction technique by using Milliman's theorem. Now let us try to use this technique and apply. Okay, we need to reduce this network into a small circuit consisting of an V equivalent. Okay, so this is the value of V equivalent, and we need to have one more branch. This is called as R equivalent, and now we need to insert this resistance RL. Okay, so this is, then we need to find out the current IL. So what is the formula here we are going to use to find out V equivalent? Let's try to do it. So V equivalent is equal to V1 into 1 by R1. You can see here the current in this direction is like this. Okay, here it is flowing in this direction, and here it is flowing in this direction. So whenever the current is leaving, you can see here what is the what is the leaving terminal here. Let's try to take all in the same direction. So whenever the current is flowing in this direction, what the polarity we have for this voltage is minus. That's why minus v1 r1. Okay, next let's try to mark the currents in this direction. If you take an opposite direction, just you'll get negative. No need to bother about that direction of current, just we have to mark the polarities of the voltage. And again, current is flowing in this direction. Whenever it is flowing in this direction, then now we need to write down the what the leaving polarity we have here, minus v2 into 1 by r2. Okay, and again current is flowing in this direction. What is the leaving polarity we have here? Plus, we can write down this as v3 into 1 by r3. Okay, so divided by the values of 1 by r1 plus 1 by r2 plus 1 by r3. So what he is saying is these are three generators or three voltage sources which are connected in parallel, and now we are using the Milliman's theorem and finding the equivalent circuit, the Milliman's equivalent circuit, and we are finding the current across the branch and ohm. So the formula is like this. So this already I discussed in the previous lecture. If you want to review, just go through the basics of in the lecture 2043, then you can understand better. Okay, so now just substitute the values. Minus, you see here current is leaving in this direction. What is the leaving polarity? Minus 4 into 1 by r1 value is how much? 4. Minus, so what is the voltage? Minus 2 into 1 by 4. Next one, plus 10 into 1 by 4 divided by 1 by r is how much? 4 plus 1 by 4 plus 1 by 4. Okay, so whenever you use your calculator and try to solve it, 2 ones are 2 twos are, and try to use your calculator, and you will be getting this V equivalent voltage is 1.33 volts. And you can see here, I am going to find out 1 by R equivalent is equal to how many resistors are there? 3. 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R equivalent is equal to 1 by 4 plus 1 by 4 plus 1 by 4, and then you are going to get the R equivalent value is 1.33 ohms. This is 1.11 volt and 1.33. Just replace in this equivalent circuit. V equivalent is how much now? 1.33 volts, and R equivalent is also 1.33 ohms, and RL is already given in the problem is 10 ohm. So how to write down the current IL? So current IL is equal to V equivalent. So you see the current is leaving, but the leaving polarity of the voltage V equivalent minus 0 divided by R equivalent plus RL. Okay, so V equivalent we can write down it as 1.33 divided by R equivalent is 1.33 plus 10. Okay, so just substitute in the formula, then use your calculator, you will get the current as 0.1173 amperes. That's all. Okay, so this is the current IL across the load resistor RL using Milliman's theorem. So same problem. Okay, now if the question is not asked in this direction, sir, what to do or how to verify whether my answer is correct or not. So let's try to do by some other next method, same method, but we are not using any Milliman's theorem. Okay, so just have an focus on this. So this is by using millimans, but if the question is asked, find the current through RL. Okay, very simple here. So I want the current in this branch IL. Okay, how to find out? It's very simple. See here. So this node is a common node. I'm marking this node as Vx, and automatically the voltage at this point is also Vx, and here also it is Vx. Okay. So now I'm going to apply the nodal analysis. I'm going to mark. So if you want, I will draw it neatly for more clarity. So this is the source given to us because there are already some polarities are marked. To overcome the confusion, I'm redrawing the network for more clarity. So this is what the problem given to us, and is asking the current IL, okay, where with 4 volts, 4 ohm, 2 volts, 4 ohm, 10 volts, 4 ohm. He required the current. So this you consider as some method 2. We are not using Milliman's theorem, but we are cross checking whether the answer what we have been obtained by the above is correct or not. Okay. So for this, I'm going to assume this as a node Vx, and automatically this 0 plus Vx minus 0. This is also Vx and this is also Vx. I am assuming the current in this branch is some I1, the current in this branch is I2, the current in this branch is I3. Okay, and current is already leaving this branch. So in order to simplify it, I am going to apply nodal analysis is indirectly applying Kirchhoff's current law at node Vx. Okay, so here any entering currents are there? No, all are leaving current. Therefore, entering current is equal to 0. So at this node, what is the leaving current? I1. So I1 plus what is the next leaving current in this branch, which is nothing but I2. What is the next leaving current in this branch? I3. And what is the next leaving current? IL. Now we have to separately. Uh, so we know the formula for current I equal to V by R. How to write down this branch current? So plus Vx, high potential, minus, you see here where it is there, plus 4 divided by 4. Okay, plus how to write down the current in this branch? High potential, and you can see here what the polarity of this voltage, plus 2 divided by 4. How to write down the current I3? So we can write down Vx. So this is how much? Minus Vx minus 10 divided by 4. Okay. And how to write down the current IL? IL I can write down it as current is flowing. This is nothing but Vx minus 0, Vx minus 0 divided by 10. Okay, so just use your calculator, segregate these terms. So 0 is equal to Vx by 4 plus 1 plus Vx by 4 plus 2 by 4 plus Vx by 4 plus Vx by 10. Okay, when you move this term, minus 1 minus 2 by 4 is equal to, take Vx as an common term. So when you take Vx as a common term, then you are going to get 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 10. Use your calculator, then we can find out the values of this one. So here also you are having minus 10 by 4. Here also you get it as plus 10 by 4. Okay. So when you solve it, then you are going to get the value of Vx is equal to 1.1764 volts. Okay, so this is the voltage I have been obtained by our nodal analysis. But what I require is IL. So how to write down IL? So how to write down this current IL? IL is equal to Vx minus 0 divided by RL is 10. So what is the value of Vx? We already obtained which is 1.1764 divided by 10. 1 by 10 means this is nothing but 0.11764 amperes. You verify the answers both. So you can see here answers are same, where we can conclude the method what we have done by Millmans is also correct, and by model also we cross check. So this is, if the question is asked directly find the current across the RL, directly you can use this method. There's no need of using Millmans. If question is specifically asked try to solve by Millmans, then you can use this procedure of solving. Okay, but answers are same. Okay, hope you are able to understand. So if you feel my content is useful to you and my explanation is good, please give a like to the video, and please share it with your friends those who are studying the same subjects. If you have any doubt or any confusion, let me know in the comment section. I will answer your comments. And if you're watching the channel for the first time, please subscribe to my channel, which will benefit us to do more videos for us, and which is like a boost for us to do more videos. And kindly encourage this kind of videos for the benefit of students as well as for the faculty. So thank you for watching the video. Yours obediently, Ram. Will meet in the another video. Thank you for watching.